Hey, what is up, guys? This is just a disclaimer. I'm sorry that this explanation wasn't that great. I think it still works. I think you'll understand the problem by the end of it, but it wasn't as quick and as clear and straightforward as I wanted it to be, but I don't have the time to re-record it. But that's that. I hope you still guys enjoyed, and I hope you guys benefit from it. If you didn't, just let me know, comment below, and ways I can improve. And let me know, seriously, if you guys want me to start using diagrams, because that's something I've been thinking about for a while now. Hey, what is up, guys? We're back with another Leetcode problem. We're doing problem number 1595, minimum cost to connect two groups of points. You're given two groups of points where the first group has size 1 point, the second group has size 2 points, and size 1 is greater than or equal to size 2. The cost of connection between any 2 points are given in a size 1 by size 2 matrix, where cost ij is the cost of connecting point I of the first group and point j of the second group. The groups are connected if each point in both groups is connected to one or more points in the opposite group. In other words, each point is in the first group must be connected to at least 1 point in the second group, and each point in the second group must be connected to at least 1 point in the first group. Return the minimum cost it takes to connect the two groups. So basically, every node in this side has to be connected to each node on this side, and each node in this side has to be connected to every node in that side. So we have the example here, cost 1596, 36.2, and we see the minimum cost would be of connecting the two sides would be 17. So we have 1 to A, which is 15, and 2 to B, which is 2. And so this results in the total cost of 17. Okay, so how are we going to approach this problem? There's a number of ways that I tried and I ended up failing. There was 2 ways that I tried doing, and both ways didn't work, and then I ended up finding the optimal solution after that. But anyways, so the first thing that I tried doing was I thought maybe we'll just act like all the points are connected originally, and then I'll start removing all the maximum ones. Meaning that I'll act like 1 is connected to A and B is connected to 1 and 2, and so all the points are already there, and I'll start removing the edges that have the total cost while keeping all the nodes intact, while keeping all the all the nodes intact, like connected to each other. So basically, if I end up removing this cost, and that means either of the two nodes, if I end up removing this edge, and that means if either of the two nodes are no longer connected, that I can't remove it, and I won't remove it. So that's the approach that I took at first. I'll link that solution below. It wasn't really a solution. I'll link that attempt below, because I asked in the discussion board why that wasn't working, and then someone explained to me. So it was a good example as to why that wasn't working. But that won't work. The second approach was okay, fine. Let's just start pairing them up. So I'll do 1. I'll grab the minimum cost, and I'll have it pair with so 1 has the edges connected to A and B, right? And I'll find the one that's minimum, and I'll connect that. Then for 2, I'll do the same thing. And then for anything else, I'll keep doing the same thing. And then on the right side, whatever's left over, I'll also do the same thing. If anyone hasn't been connected to the left side yet, then I'll just grab the minimum cost and I'll start connecting them. That also won't work. I kind of walked through as to why his approach as to why that wasn't working. For example, let's say you have A, B, and C, and then you wanted to connect to 1 and then 2. So if you connected A to, and these are all the edges, right? So let's just say I was grabbing the minimum cost. So let's say I connected A to 1 or A to 2. Which one is cheaper? These are the 2. I'll do A to 2. So I'll say A to 2 is 3 instead of doing 100, right? And then I'll connect A to 2. So imagine A and 2 are connected. Then I want to connect B. So I'll connect B with anything that can only be connected to 2 over here. So I'll connect to 2. So B2, that's equal to 2 right there. Then I have C left over. C is connected only to A over here, to 1 over here. So that will be C1 is equal to 101. Yes, I realized my problem. So that will give me an optimal solution, right? But let's just say I started from 1, 2 first. Let's say I started from this side first, and of course the order doesn't matter. I can think of an example where this is like this, right? The order doesn't matter. But let's just say I started, so in this solution, in this case it would work. But now let's say I started from 1, 2. So then I'll start from the right side. So I say 1, and I'll say what's the minimum cost for 1, and we have C, so I'll pick 1A, which is 100, right? Then I'll go to 2, which one is minimum? Oh, B2, which is 2, right? And then I'm done on this side, so I'll try to see the leftovers on this side, and I see C is still left over, so I have to connect C. Which one connects C? So to 101. So I'll connect 1C, which is 101, and I'm getting something like what, 203 or something like that, 203, which is way more then as we saw earlier, the minimum cost that we were able to get, which was just 106, right? Which was just 106. So this approach also won't work. So the way you're going to approach the solution then is now you're going to have to try all the left pairs with every possible right pair, right? So I'm going to have to try A with 1. So let's just use the example for now. Well, it doesn't really matter. So I'm going to have to try A with 1 and then A with 2. And then B with 1 and B with 2, and then C with 1 and C and 2. So that's the approach that we're going to have to take. Okay, so I'm going to try A with 1, and then I'm going to C with B with either 1 or 2, and then C with either 1 or 2, and then I'll end up with a cost at the end of that, and then I'll save that, and I'll see if and then that will be one possible cost. And then I'll try again A with, instead of starting with 1 this time, I'll start with 2 this time, and same thing with B. I'll do 1 and then 2, and C with 1 and 2, and I'll get the cost at the end that way. Okay, so we're now back take a break. But anyway, so now how are we going to approach this problem? How are we going to code this into a loop? Remember we talked about that each node in this left side is going to have to connect with each of these nodes on the right side. So the way we're going to do this is this. So we're gonna have a helper function, right? And it's going to take in the current index on the left side that we're at. So whether we're at A or B or C is going to let us know where we're at. So that's going to be an index group 1 index, meaning we're either at A or B or C. That's what that's going to tell us. And then we're going to grab the node at this index. Just imagine. So we're going to grab this node at the index, and we're going to connect it with each node on the right side. So we're going to go through all the nodes on the right side for node N2 in group 2, right, which is the right side. We're going to connect node 1 at G1 index, group 1 index, with N2. Okay, we're going to connect this node with the right node. And then what we're going to do then, so after we connect that, then we need to try the next node at the left side, right? So I'm going to call helper with group 1 index plus 1. Meaning, I try connecting A with one of these, then I'm going to try connecting B with one of these, then I'm going to try connecting C with one of these. Okay? So first A gets connected with 1, then B will connect with 1, then C will get connected with 1, and then eventually, if group 1 index is equal to group 2 size, meaning that we have no more nodes to see in our group 1 or our left group, then what we have to do then is we have to go through our nodes on the right side and see which ones haven't been paired yet, which ones are left over. So we're going to go through node N2 in group 2. If not paired, if they're not paired, connect them. If they're not paired, connect them with the minimum cost. We can just connect them with the minimum cost now. We can just connect them with the minimum cost. At the end of that, we're going to get a final cost. We're going to get a final cost. And we're going to add all these costs up of connecting with all the ones that we connected A for, and then B, and then 2, and then we're going to save that. We're going to save that, and that's going to be our final cost for that current pair of connections. And we're going to try that, like we talked about, with which each node on the left side connecting to each node on the right side. So A is going to connect with 1, then 2, or B 1, 2, C 1, 2. It's going to try all those out, and then it's going to look on the right side at the end of all those recursive calls, right, our base case. Once we finish all these, it's going to look at all the leftovers over here on the right side, on group 2 side, and it's going to use the minimum cost and connect them that way. So that's how we're going to approach this problem. I'll look at the code in 1 second, but let's just talk about some things real quick. How are we going to keep track whether group 2 was paired with something from group 1, right? So we can do this properly. One, we're going to use a bit mask. So we're going to use a bit mask to check whether group 2 has been paired already or not, because group 2 will only have a limit of size 12, right? It won't go past size 12, so we can use a bit mask. We can just flip the bits to check whether they've been paired or not. Number 2, how are we going to know what's the minimum cost? We don't want to keep going through all the nodes on the left side each time. So before we call any of these, we're going to go through group 2's edges, and we're going to find the minimum cost for each one of these nodes, and we're going to save them. That's number 2, and you'll see what I mean by that in just a second. So that's number 1. Number 2, Oh yes, number 3 is we're going to use dynamic programming or memorization to keep track of the cost that we've already possibly calculated. Meaning that if I see that I've connected A with 1 already, and then I've connected B with 2 already, then I can check when I hit C the second time, because let's say the first time I connected A with 1 and then B with 1. A with 1 and then B with 2, and then I get to C. So I see now when I'm at C, I see A is connected to 1 already, B is connected to 2 already, and that means C is left over, and I calculate C. The second time I can check again. I can connect A to 2 and then B to 1. Remember, the first time we connected A to 1 and B to 2, and now we're connecting A to 2 and B to 1, and then I get to C again. And once again, I see A is already connected, B is already connected, 2 is already connected, 1 is already connected, and so I already calculated the C value for that already, so I could just use the previous calculation already. That's what I mean by the DP. So if you look here now, we're going to walk through this code. So I'm going to get the cost of group 1, the size of group 1, and size of group 2. I'm going to create my DP array. So it's going to be group 1 to group 2, meaning whether group 1 has been paired with group 2 already, right? Or not really. When this index over here, right? This is going to keep track whether group 1, which nodes in group 1 have been paired, right? This is also going to keep track of which nodes in group 2 have already been paired, but they're going to do it differently. Group 1 is going to be keeping track of whether because if we reach the current index, that means everything before it has already been paired. So that's how that's going to keep track of it. Whatever index we were at, that means everything before it has already been paired. And this one is going to keep track of what nodes have been paired by using the bit mask as we talked about, meaning whether this int has been seen already. So that's that. So that's the DP 2D array. Then this part over here is going to calculate the minimums as we talked about for this step. Connect with the minimum cost. Remember we said we're going to find them originally at first. This is going to find the minimum cost for each of the edges, each of the nodes in group 2. And then we're going to call this a helper function. I don't really know why I named it DFS. It's not really DFS, kind of, not really. What this is going to do, well, first we're going to check if we've calculated this already for this node, because remember, for this group 1 index, if we reach this index so far, that means everything before we've already calculated. So all those nodes in node 1 have already been connected. And then same thing for group 2, we'll use the mask to see if those nodes in node 2 have already been connected. So if we've already calculated this set before, this set of connections that we've seen already before, then we'll just return the answer for that, right? Because the rest of the code following is going to be exactly the same as what we calculated before, because we've seen these arguments already, right? We've seen those arguments already. Then what I'm going to do is ignore this. We're going to come over here. As we talked about, we're going to go through this node in the left node and we'll connect it with each of the nodes in the right node. So this is what this is doing. Over here, I'm going through all the nodes in the group 2 or the right side, and I'm going to connect it. This is going to get the cost of the connection, right? I'm going to connect it with my node, my current node on the left side. So A with 1, A with 2. This is what this here is doing, right? And then I'm going to grab the minimum cost for each of those. So I'm going to either use the minimum cost that I already found, or I'm going to see if this one had a better connection. Meaning, did A connecting to 1 and then continuing on, was that better than A connecting to 2 and continuing on, right? This is what this is doing. So as you can see right here, I'll pass in the next group index, meaning I'm going to move to B now. I'll pass in my new bit mask for my group 2, meaning what this is doing now is over here, you just have to learn bit mask. I guess I'm not going to really go into explaining this right now. It's going to take another 5 minutes. But this is what this is doing. I'm setting the bit in node in the group 2 side to true, meaning it's been connected, right? So group 2 is now connected. Then I pass in the cost, right? the cost the same, the 2D matrix, right? I got confused with the cost. They should really rename this. And then I pass in the DP again as well. So these arguments are always going to stay the same. What is going to change are these two beginning arguments. So anytime we've seen these two arguments already, we'll just return the previously computed answer. Then I save the answer and then I return. Then again, over here, if, remember as we talked about, if I reach the size already, right? Meaning I finished everything and now I finished all the nodes in group 1. What I'm going to do then is try to connect the nodes in group 2, anything that's left over. So I'm going to go through all the nodes in group 2 and I'm going to check if that mask hasn't been set yet, meaning it hasn't been connected yet. If it hasn't been connected yet, I'll connect it with the minimum cost edge. The minimum cost edge to connect it to group 1. That's that. Oh man, I really should start using diagrams. It's super hard to explain this without diagrams. But anyways, then I connect the minimum cost. I add them all up. And then I return the sum cost for that. Before I do that, I save it as we talked about. And then I return that. This is that. I don't know what I'm saying at this point. I really have to start using diagrams. And that's the answer. I hope you guys enjoyed.